Hello, and welcome to today's E360 webinar titled The Role of Emerging Refrigerant Alternatives, CO2, A2Ls, and R-290, brought to you by Emerson. My name is Kate Henderson, and I will be your moderator for today. We have just a few announcements before we begin. Please note that this presentation's audio is provided by phone or through your computer's sound system. In addition, you may type questions that you have into the text area and hit send in the Q&A panel throughout the webinar. We will answer any questions at the end and send out answers to questions that we may not get to in the coming days. If you'd like to revisit key sections of today's webinar, it will be available on demand at e360hub.emerson.com/webinars a few days after this live event. You'll also receive an email in the next few days with a link to the recorded event. Discussing today's topic will be Kurt Kanapke, Vice President, Solutions Strategy, Cold Chain, and Katrina Kreitz, Director of Strategic Marketing for the Cold Chain. As Vice President of Solutions Strategy for Emerson's Cold Chain business, Kurt Kanapke is responsible for engaging customers and stakeholders in the cold chain industry and guiding them on how to optimize the total cost of ownership of refrigeration systems. He provides expertise on the integration of Emerson products, solutions, and services that solve customers' unmet needs and pains. Kurt has 25 plus years of refrigeration industry experience at Emerson in various roles. He earned a bachelor's degree in mechanical engineering from the University of Toledo and both a master's degree in mechanical engineering and an MBA from the University of Dayton. He holds multiple patents on technologies pertaining to refrigeration systems. In her role as Emerson's Director of Strategic Marketing for Cold Chain, Katrina Kreitz takes a holistic approach to helping customers solve problems. Her responsibilities encompass the strategic marketing of Emerson's major market segments of cold chain, including food retail and food service. These responsibilities include, but are not limited to, understanding market trends and dynamics in order to develop key insights into the market, assisting customers in their development initiatives, and implementing go-to-market strategies. Katrina has 8 years of industry experience. In addition, she has 20 years of business-to-business marketing experience, including product and market management, marketing communications, and e-commerce. Katrina earned a bachelor's degree in business human services from Urbana University and an MBA in leadership innovation and change from Wright State University. The webinar will now begin. I'll hand it off to Kurt and Katrina.
Thank you very much for that introduction. So I'll kind of kick it off by talking about what are we actually going to talk about today. So we're going to start out talking about industry trends and regulations, given a very high level overview. We'll then talk about some system comparisons, considerations, and then transitions. Global warming potential applications, low GWP applications across those different applications. Then we'll deep dive into new store and remodel architectures and refrigerant considerations. When you have an existing store fleet, you have a lot of different choices coming your way. And then we'll wrap it up with just giving a sneak peek into the rest of our webinar series throughout the summer. Kurt?
Thanks, Katrina, and thanks, Kate, for that great introduction. As you guys have heard, my name's Kurt Kanapke. I'm excited to be here today and share some of the information about the industry and our projections into the future, as well as evaluating low GWP systems. Looking across the last 2 years, what can I say? It's been an interesting time with many dynamics creating new challenges for our industry, and those new challenges bring opportunities. If you look at what's been going on, we've all had to deal with the pandemic. There's been numerous changes in shopping behaviors, and as always in our industry, we seem to be having some changes in our regulatory compliance of how we have to design and operate our systems. And as always, as an industry, we're looking for the best total cost of ownership, which includes first cost, operational cost, as well as the maintenance cost. But then the evolving emissions and care for the environment has introduced de-electrification of not only our electrical grid, but almost everything that we do today in our environment, as well as large companies setting net zero targets and finding ways to reduce their CO2 emissions to near or at zero levels. So a lot of interesting changes coming in the last 2 years, and I don't see those changing and it being a very dynamic time over the next couple years.
Yeah, definitely a lot of changes. If I just think back through my last 20 years of shopping, for example, now from going from the grocery store when I first started out to everything getting delivered at home, and that infrastructure is really important, that it's changing and things are moving a lot faster, I feel like, in the last 10 years.
So along with many customers in our industry setting net zero targets, we're excited to announce Emerson has followed and done something very aligned with those overall goals that others have been setting. We have set a goal for 2045 for Emerson to hit across scope 1, 2, and 3 a net zero as calculated by a science-based emissions calculations. Along the way, we are setting milestones for our path in 2030 for that by scope 1 and 2 will be net zero by that checkpoint. We are also looking for a absolute reduction of our scope 3 emissions of 25% by that 2030 timeframe. As well as beyond the emissions that were in our 3 scopes, we are also looking to change how we source energy and the energy that's being used across our operations and our office buildings throughout the various buildings in the Emerson enterprise. So switching back to the refrigeration industry, there was a earlier webinar that was completed that you guys can review, but essentially here's a summary of the activity that's going on in the regulatory space that's affecting our air conditioning and refrigeration industry. First, we're looking at California to lead us through some of these emissions and these actions. And their California Air and Resource Board has driven that and set various regulations. If you look at refrigeration, for example, starting in January 1st of this year, any system above 50 pounds has to use a refrigerant less than 150 GWP, which brings some interesting challenge in how we design the refrigeration and air conditioning systems across those applications. But then if there is a charge limit where if you're less than 50 pounds, you have to follow the SNAP 20 and 21 regulations, which is approximately less than 1,400 GWP and could be lower based on applications as defined by those SNAP rulings. Looking at the air conditioning equipment that we use across our commercial buildings, we are looking to hit 750 GWP or lower when we're deploying them in California, and have different deployment years by the type of equipment that we're deploying, whether it's a RTU or a process chiller or other air conditioning equipment. Not only did California come out and set regulations on new equipment, they also set regulations on their existing install base, which we'll go through a lot more detail later. But essentially, there's a 2026 touch point and a 2030 target that those enterprises must reach to meet that regulatory compliance. And as we look across, the nation, there's a lot of activity outside of California. First, starting with individual states inside the Climate Alliance that are either following California's lead or enacting the EPA SNAP 20 or 21 regulations. While we're excited to see those states take early adoption, however, that creates a very complex environment for us as an industry to roll out solutions across the country. It gets very state specific and not consistent across those states, what those rules ask for and require, as well as different deployment dates across those states. I'd reference you back to the refrigerant webinar to get more details on exactly the state-by-state regulations. The exciting thing that we're seeing that was enabled by the AIM Act was to empower the EPA to initiate nationwide regulations, which are in process of being developed now. They are looking at it from a production base, and you can see the phase down reduction based on a CO2 emission equivalent listed here, but then also used by a use base with implying sector-based rules for the use of what refrigerants are allowed in what application, as well as how you manage that HFC in both new stores and service activities. Rounding out the quick regulatory update here, as we're seeing more and more regulations, either nationally, statewide, to challenge industry to go to lower GWP systems, we do need our regulations for our industry to catch up to those low GWP. So there's use of UL and ASHRAE regulations, as well as SNAP approvals that are being updated for the various A2Ls that we're seeing introduced, and defining those charge limits, as well as increasing the charge limits for A3, and all those regulations are finalized either now or will be finalized by the end of the year, with the building codes quickly following in 2023 and 2024.
There's a link on the top of this chart that goes through, it'll link you directly to our past webinar for the deep dive on the regulations.
Looking at the need to go to lower GWP refrigerants, this is a landscape that shows the various refrigerants that are available for AC, medium pressure refrigeration, or low pressure refrigeration. While this is not a comprehensive list, it does give you a nice, easy way to kind of, at a high level, map your way to what options that you should evaluate in more detail. To just explain the chart, we have GWP refrigerants of the different options plotted on a XY graph, and across the bottom of the graph, you see a scale, which is the GWP of the refrigerant itself by either AR4 or AR5. And then we are plotting the volumetric capacity of that refrigerant on the y-axis. You have it relative to a common low pressure refrigerant on the left as 134A, and on the right, it's based off of 404A. So you can quickly see the differences in capacity, as well as the levels of GWP that you achieve through the journey. And as you guys probably already know, it's very difficult to achieve a direct drop-in refrigerant from a capacity, as well as a glide and other thermodynamic properties. So there's little nuances and unique choices that need to be made as we navigate our way through this, which we'll go through in a little bit more detail later. But essentially, at the top of the graph, you're looking at some 410A or air conditioning options, and 452B and 468C. And then in the middle of the graph, you've got 404A way on the right-hand side, which is so far off the scale, we've illustrated it here. And you see the paths to the commonly used refrigerants of today in 448 and 449, kind of right in the middle of the chart. And then going and looking at the lower GWP options, you see there's the line below 150. So if you look past that line, there's 455A and 454C and 457A, as well as ammonia and propane as some of the natural options. And then we're focusing on the lower pressure refrigerants, or the 134A, like you see 134A on the lower third, kind of in the middle. But then the available options, you're really looking at, the true HFO refrigerants in 1, 2, 3, 4, YF, and ZE as potential options for that lower pressure. There's also, rounding out the natural options, there's CO2, which has a very high volumetric efficiency, but obviously a GWP of 1, which rounds out the different options. So when you're looking at this, many options exist, and one option is not going to be a solution to all of our problems that we're looking for. And the unique application may have a different path, or your specific customer case may have a different path. So I'd encourage you to interact with industry experts or your Emerson experts to help you guide your path to low GWP refrigerants.
Thanks, Kurt. So now we're going to get into some different options and considerations based on applications for those transitions.
Summarizing that last chart kind of into three categories, and the ones that we see will be emerging the most, we have the regulatory drivers driving us to lower GWP systems, and we have propane or R-290 that is regulatory compliant and a GWP of 3, but has some charge limitations of currently 150 being expanded to 300 to 500 grams. That will be a good option, and that's available today. You have CO2, which is also regulatory compliant and has an unlimited charge regulation or charge limit, and is available today. And then a group of refrigerants that we have categorized as just A2Ls. And while that is regulatory compliant with a GWP of 150, roughly 150 GWP, there will be some limits on the maximum amount of charge, approximately 175 pounds, and that varies a little bit by the chemical mixtures of the A2L refrigerants themselves, as well as the LFL of each individual refrigerant. The one unique thing about A2Ls is while there's a lot of development going on, they are limited in market availability today, and we expect trials to be coming out of the AC and refrigeration industry in 2022 with further adoption in later years. Food retail, and looked at what we thought would be the primary market or refrigerants that are adopted in the primary applications. And we believe CO2 has been increasing adoptions here in the United States and across the world in those food retail systems, and will continue to do that, and will end up being the primary refrigerant in food retail. While A2L has been limited adoption to date, we believe that will gain traction and come in as the second most used refrigerant in food retail, with propane when use of micro-distributed systems or even self-contained systems. Either air-cooled or water loop would be the third most used refrigerant across food retail in the future. When you look at food service, the dynamics change because of the size of the system, the number of system that are out there. There's a lot of uniquenesses between a under-counter unit, a reach-in, an ice machine, or a walk-in. But when in generality, we believe in food service, as long as you can get the system designed with a propane charge under the charge limitations, we believe the majority of the industry will adopt propane, with A2Ls being the second most adopted refrigerants due to increase in charge limits over propane, but the reduction in cost over CO2 from a first cost and an energy cost, as well as the complexity that CO2 would be introduced to a less diverse contractor base that normally services food service applications.
Yeah, and for the convenience stores, we can kind of see a hybrid depending upon the refrigeration intensity and where they would align themselves from an architecture standpoint.
Summarizing those drivers and looking at where we stand today and what will be the transition rate throughout the near future out to 2030. This is a high-level estimate on Emerson's perspective on how new stores and remodel stores will change in the various applications. What's driving these transitions obviously are the regulation, but then sustainability and really total cost of ownership in the specific applications. So if you look at self-contained, as I mentioned earlier, the majority of those systems can be utilized with a small charge and will transition to R-290, with some being maintained with a traditional A1 refrigerant, and some choosing to move to an A2L when the charge limits get a little bit larger than the R-290 charge limitates. In remote systems, so walk-in systems with a unit cooler and a remote condensing unit or similar, we believe that A2L will be the primary refrigerant adopted in that type of architecture, with some use of A1 if you can keep it underneath the system charge limitations, as well as CO2 seeing a small adoption in that architecture. When you look at a little bit larger systems and you start talking about supermarket racks, that are, traditionally, centralized systems or even scroll packs that are used, we see a transition more into the CO2 systems, leveraging the size where that they start to make sense, and then also having some adoption of A2L. But in here, it's very difficult to create a supermarket architecture that's below that 50-pound charge limit. When you start to get into the light industrial or the industrial space, ammonia will still play a presence, but you're going to see an introduction of CO2 systems there, as well as some A2L in the light industrial.
So now we're going to get into each one of these different systems at a high level. Keep in mind, or these different refrigerants at a high level, keep in mind that this is meant to be an overview. In our following webinar series, we'll go deeper into each one, R-290, A2L, and CO2 systems. So look forward to that.
First, diving into the smaller systems and looking at where can propane be applied. And we've been seeing more and more industry acceptance of using propane. Primarily, all of our domestic refrigerators have propane in them, and they're being adopted more and more into commercial refrigeration. As all of us know, there is a UL limitation of using propane up to 150 grams of charge, which really stops or cuts the ice machine and the commercial reach-ins and some walk-ins kind of into applications that can, and then those that are too large to use propane. What's exciting is to see the work that has been done around our regulations, increasing that charge limit from 150 to 300 or 500 grams, depending on the type of appliance that you're applying it to, and that will increase the size of the applications that we can apply propane to. So you can see kind of where that stands alone. Not only is that increase in that charge limit, but we're starting to push the EPA SNAP to include propane into a more comprehensive list of applications. And right now you can see vending machines are not on that SNAP approved list, as well as some of our walk-ins that are in a remote location for the condensers. So we were hoping that the EPA will evolve that and include propane in those applications going forward.
Yeah, and keep in mind that, typically those smaller applications use the recep compressors, and Emerson has a full lineup of scroll compressors for those larger size applications to help with your particular application.
So moving on to CO2. The natural adoption of CO2s in larger systems and configured in a booster system, very similar to the systems we used to use when we were applying R-22 back in the day. But essentially, that's tying in the low temp system into the medium temp system and using a lot more electronic controls, not only to coordinate the two suction groups, but also to tightly control the superheat off of our evaporators, both low temp and medium temp. And because of the thermodynamic response of CO2, that superheat control is very important in these CO2 systems. Not only is it a more complex architecture, but there's some nuances that we have to adapt to as an industry to learn the new architecture and some of the nuances when you're dealing with a gas cooler and a flash tank that ultimately reduces the pressure that is introduced back into the human occupied space or store space appropriately. The nice thing about introducing more controls is that we have greater visibility on how we're seeing the systems and what we can do from a remote troubleshooting and understanding of how that system's operated. And Emerson offers a complete portfolio of products from compression to valves to drives to rack controls, high pressure controls, as well as case controls when you look across that system.
Absolutely, and the new Illumina E3 CO2 controller is specifically designed for CO2 systems, so it's a great addition to our lineup as well.
When applying CO2, it does operate in a subcritical and transcritical mode. And when in that transcritical mode, the overall efficiency of that system is dramatically reduced. And so the industry, as well as academic and research organizations across the world, have been looking to see how do we apply different technologies to the CO2, the basic CO2 system, and improve that overall energy efficiency. And therefore, Emerson, based on industry demands, actually went through and did what we call the CO2 climate study. And essentially, it's evaluating those different high ambient and other advanced technologies that can be applied to a CO2 and driving insights that balance the total cost of ownership based on geographic location. This specific effort, we've used both the ASHRAE and the IEC climate zone regulations and looked into various major cities inside those 13 climate zones and actually used the bin of both dry bulb and wet bulb to complete energy comparisons between all these scenarios and of system architectures that you can apply. And the insights dramatically different depending on what specific location you're in, and sometime within the same climate zone, the results will drive you to a different answer. So I would encourage you to engage with your Emerson representative to understand, based on geographic location, what's my best balance of total cost of ownership when you're looking at dry gas coolers, adiabatic gas coolers, parallel compression, heat reclaim, or the use of ejectors that can be applied to CO2 transcritical booster systems.
Yeah, it's definitely not a one-size-fits-all approach. In the resources link on your screen, if you're interested, you can sign up for a discussion with our experts on going deeper into this. And then future webinar series will also talk a bit more in detail around the results of the climate study. So we're looking forward to hearing about a little bit more about that.
So now let's turn our efforts to looking at the emerging class of A2L refrigerants. These A2L refrigerants are not a drop-in replacement for today's refrigerants, so there's different nuances that we need to keep in track. If we got, what you're seeing here is different comparisons on the left of the different refrigerants, as well as a few baseline references of R-290, 448, and propane kind of as a reference point. And then kind of in the middle here, we're looking at the medium pressure A2Ls, which Emerson's in the process of approving for their compressor and condensing unit product lines, with samples available across all three of these refrigerants today, and production either released or will be soon released in the near future. Looking across those medium pressures, there's various pros and cons for each of them. If you look at 455A, for example, it has a very good capacity match to 44A, but then introduces significant glide on the evaporator. And then if you look at 454C, while it has a little bit less glide, it does have a capacity drop when you're looking at medium temp capacity that you're getting from that refrigerant. If you look at 454A, it has less glide, an increase in capacity, but it does not quite meet that 150 guideline that we're seeing the regulations being driven by. So different trade-offs between those refrigerants. Like Katrina said, no one answer is going to fit all scenarios, but that's the medium pressure refrigerants that we're in the process of approving. And then looking to the further to the right, you're actually looking at the low pressure options that are in consideration in the industry. You can see differences between 515A, the HFO blend 1234YF, as well as an interesting candidate that has been introduced and ASHRAE's approved and given an ASHRAE number to of R-471.
Yeah, so lots of different properties depending upon how you choose those refrigerants. So obviously design requirements will definitely need to be considered as you move forward with different systems.
Not only do you have to look at what refrigerant you're choosing, but then also look at how you will be designing these systems with the architecture inside those A2L systems. If you look at what considerations are being defined in the UL and the ASHRAE standards, you're going to see considerations on a lot of different factors. The first one being is charge limitation I talked about earlier. And we're seeing charge limitations will be about approximately 175 pounds. There will be also steps you need to take for mitigation around A2Ls and if the potential of a leak does occur. They are defined whether you're using a display case, a walk-in unit cooler, or on the high side you're using condensing units or racks. Those specifications will go through the details of exactly what you need to be doing for mitigation. But the biggest introduction that we see is going to be the use and the requirement of refrigerant leak sensors on the evaporator or near the evaporator, as well as the use of safety shutoff valves to isolate different portions of that system that have or may develop a leak, as well as have the ability to take mitigation actions, either running evaporator fans or creating an instance where you create a pump down situation to comply to the various safety regulations that UL and ASHRAE are putting in place. As a quick high-level example, which a future webinar will go in more detail, we're kind of looking at what components need to be applied to both the low side and the high side system. Here's a quick reference that looks across your display cases and your walk-in unit coolers on the low side, and the use of a controller on those evaporators, as well as the introduction of leak sensors and isolation valves will be required on the evaporator side. And on the high side, while we're going to be traditionally using a rack controller, that the use of leak sensors and isolation valve really depend on the application and the size of the equipment and the location of that equipment, whether it's indoor or outdoors. Rounding out, the low GWP alternatives, here shows the use of R-290, A2L, CO2, and ammonia by the various applications and where we think, relating back to that transition chart, where it's going to be used the most, as well as showing the comprehensive platform that Emerson does offer to the industry from controls, compression, and valves.
Okay, so now we're going to get into talking about, Kurt talked about those refrigerants and how they apply in different specific applications, but how do they look compared to each other? That's really what we're going to talk about in this next section. So I'm going to go through some low GWP options for new and remodels. So Emerson has worked on a total cost of ownership study, and the idea behind this was to be able to have conversations with our customers and the industry about the challenges in each one of those different system architectures. So we looked at a 25,000 square foot store and compared 6 or 7 different system architectures, from CO2 and naturals, refrigerants to R-290, as well as the existing baseline of an HFC system. And we wanted to get mostly an apples to apples comparison so that everything was very similar in the approach. So we had laid out refrigeration schedules, refrigeration floor plans, electrical floor plans, and electrical schedules for each one of those different architectures, refrigerant architectures in the store layout. The idea was to be able to deep dive and get insights as to what the trade-offs were between those different systems. So we have both first cost and total cost, which I'll go into the results next. So if you look at a medium-sized supermarket total cost of ownership, the first cost was the installation as well as the systems and cases for each one of those different refrigerant architectures. The HFC rack was our baseline, and any new system really today, the challenge is that it's going to come with an initial first cost that's higher than the baseline HFC racks. Obviously, with supermarkets having low capital expenses and they want those capital expenses to be consistent, that comes with a challenge from changing out these different systems with a higher first cost. So looking across, you can see that this distributed scroll pack is a pretty good representation of first cost, about 3% higher. And as we go over the HFC condensing units, those have about an 8% cost premium for first cost. CO2 is coming down over the last several years. We've seen a decrease in the total cost first cost, for those different systems. And really, depending upon what your specific architecture is, that is going to inform what technology you use to drive that 20-year cost down. Then on the micro-distributed, those are a little bit higher, about 7% over. And then the scroll booster, you could, on the last line, the distributed scroll pack with A2L, that is a very viable option for the future. However, A2L still need to catch up with regards to the codes and standards. So that's pretty much why we put it last. So the other thing I'll mention is from an energy standpoint, depending upon your location, the energy plays a huge role in that 20-year cost. The average around CO2 is about 5% higher, but looking down this line here where it's 8%, 12%, 3%, really depends upon what that climate zone, and that's why it was so critical for us to deep dive into that CO2 climate study to help you all understand and the industry understand that those nuances can really drive decisions. It's no longer a one-size-fits-all approach. The micro-distributed water-cooled, those had the highest first cost and total cost because of those energy of the pumps, and that was a little bit of a penalty. But then if you look at the distributed scroll packs with A2L, you can see that the total cost of ownership over 20 years is actually less than HFC rack systems. So a lot of great insights there.
Sorry, Katrina, thank you for pointing that out. But we just picked a specific refrigerant load and size of store, and did this detailed analysis. And so it'll be directionally correct, but as you move up and down your refrigerant or your refrigerant load sizes, as well as your building sizes, the results will change. But that's why we encourage you to, engage with, us, and we can help walk through different scenarios similar to this that pertain to your specific case.
Yeah, there's definitely technology break differences depending upon the loads. Thanks for adding that, Kurt. So some of the additional considerations to think about for retailers, or if you're helping specify, it's not just about the first cost or the total cost. What is the long-term plans for that customer? Electrical rate structures are becoming more of a thing between peak energy or initial cost and peak. So if you do something like adiabatic, you have a peak power delta, but then you're going to increase the water consumption. So is there availability of water, sewage costs associated with it? Those trade-offs will really have to be evaluated in determining what is the right architecture for you, your customers, et cetera. So in addition to that, service and maintenance skill level, I had mentioned, I think before, that with CO2, we see that the technology, that the skill set, lots of people are learning how to leverage CO2, install it, and maintain it, but there's still a gap. In some regions, that gap is more larger than others, so that's a consideration for installing CO2 systems or other systems. Heat reclaim, are you going to include heat reclaim advantages in your particular location? And of course, carbon intensity is still, it's a very hot topic today. What are the scope 2 emissions? What are the net zero goals of the retailer? That kind of gets you to that long-term goal. Everybody has different considerations for sure. Remodels are a whole different story. You're not starting from a blank sheet of paper. You're basically starting from a playbook that's already existing. So the strategies employed by retailers are going to be a lot different than a new store strategy. And in California, CARB compliance for existing facilities, they have a phase down of having 2 different options by 2023 to comply with the CARB standards. One is a weighted GWP reduction of 55% based upon their 2019 fleet. And this is a fleet calculation, so it's taking all of their existing store fleet and then reducing it by 55% by 2030. And then the other is the weighted average GWP reduction. This is that the stores need to get under 1,400 pounds or 1,400 GWP by 2030. There's pros and cons to each, and retailers will really, in order to flex their capital expenditures very well and make the most of their funds, look at it both ways, because whatever your strategy is, you might get to the solution faster one way or another, reducing the total spend.
The California Car Board set up that regulation is they originally had the end user choose what option they were going to achieve compliance by. They since revised that so that either method, as long as they're compliant by one or both, it gets them to the compliance. So no need to specify which method you're using.
So when we think about the existing store fleet, there are many different options around what you can do for CARB compliance when it comes to natural refrigerants or phase-in or just changing out the refrigerant. So we'll go into a couple of scenarios around that. Remodel considerations, however, have, depending upon what you choose, if we think about from baseline, these are checks better than baseline is a check mark, worse than baseline is an X. So if you think about first cost associated with just changing out a refrigerant, that's going to be really relatively inexpensive compared to some of the other options if you just change out refrigerant systems. But energy cost, they will probably be maybe a little bit worse with some of the other systems. We talked a little bit about those energy comparisons for those different systems in the previous charts on new stores. So those would kind of tie out to be similar. You would have micro-distributed and condensing units utilizing higher energy. Service cost, if you're only changing out refrigerant, then you're going to continue to have older stores, an aging fleet that might have higher service costs compared to adding in and changing new refrigerant systems. Reusing the cases, now this can be a big issue if you have newer cases within the last 5 to 7 years. You might not want to change them all out, but certain system architecture choices would force you to change out the cases. For example, with CO2 and micro-distributed, not being able to repurpose cases might be a challenge. Expansion valves, reusing the expansion valves similarly as the cases. And then the store disruption, I hear this all the time. We're not going to shut down our stores for a remodel, which is a huge challenge if you're transitioning to some of these other natural, the CO2 in particular. So a lot more planning has to go into how that transition is going to happen. Leak rates are a challenge with older systems. We all know that. So as new systems come on, that is a consideration to take into your plans. And then of course, the carbon emissions with the natural refrigerants and the lower GWP, that's really what we're trying to get to, is the lowest possible carbon emissions. So let's take a look at a particular example. This is the mathematical example, so we can dive up a little bit deeper. But if you have 30 stores in California with 2 systems each, or 60 systems total with a weighted average GWP of around 3,000, we calculated this based around a 50,000 square foot store. The existing store, like I said, was 3,000, and we need to either get at 1,400 weighted average GWP or a 55% reduction. When I mentioned earlier that each one of these different options are going to net you a result, possibly one over the other. So doing the calculation, as you can see on the 2 columns there, weighted average GWP and greenhouse gas emission potential, do the math both ways, basically. So if I just change out my refrigerant in all of those stores, I am going to have to touch every single store, and it gets me to the weighted average GWP of 1387, but I still have high energy and maintenance costs. With a scroll pack, you can still use your cases as they are, change out 10 new stores, new equipment in 10 stores, and then 20 refrigeration change outs to get you to the 1,400 weighted average GWP. That still has, since you have a quarter of your stores or a third of your stores that are new. You'll have a mix of better energy optimized stores and lower maintenance stores and not so new stores. Scroll booster, you can see that would require a modified expansion valve, for 55% GHG reduction there, and about a $16 million CapEx total for 17 stores touched. A little bit less energy, less maintenance because you are touching more stores. But again, with that architecture being relatively new, it has higher capital associated with it. And then rounding it out with CO2, you would require touching 13 stores to get you to that goal. And that capital would be around 26 million, higher, a little bit higher similar energy, and then maintenance. You would have a portion of your stores that would be new, so that maintenance would come down with those newer stores. With that, that ends that portion. I do want to put a plug in for our upcoming webinar series, the E360 webinar series. You can see on your screen the next one will be focusing on A2L adoption in commercial refrigerants. Then we'll go deeper into CO2, R-290, and A2L after that. So we look forward to presenting that content to you. This is, it's going to go quite a bit deeper with the technical elements.
Okay, thank you, Kurt and Katrina. So at this time, we will now be transitioning to our Q&A portion of the webinar. Andre Patnode and Brian Vinasek will be moderating this section and asking questions for Kurt and Katrina to answer. So I'll hand it off to Andre and Brian.
Okay, I've got one here. I can start off. I think this may be for Kurt. Can you hear me okay?
Yes, I can, Andre.
Okay, great. Can supermarket CO2 systems contain the entire charge during an extended downtime, or is a secondary system needed to prevent venting to the atmosphere?
So with the use of CO2 inside these various architectures, as the ambient increases, the pressure will increase throughout the system. That is not a problem as long as the CO2 system is running. However, if there is a power outage, or if the operation of that system fails because of a system or a component failure, it will go down into a shutdown mode, and then the pressures will rise the longer that system is shut off. If you are lucky enough to have that occurrence happening at a very, very low ambient, there's probably no concern. But as the ambient continues to increase, eventually you're going to hit the various pressure limits or pop-offs throughout the system, whether on the low side, the flash tank, or the high side of the system. They're all different levels. So one method to avoid having that CO2 rise to those higher pressures and hit those pop-offs, therefore venting refrigerant into the atmosphere, is to apply a small cooling system that, in that case, it's ran by either a generator or other source of alternative energy, is to make sure that the CO2 in the system is maintained at pressures below those pop-off levels. Although that's an alternative, we've seen most of the systems being deployed, at least here in the US, choose not to put that extra, I'll say, system that maintains that lower pressure, that CO2, and increase their risk on those power outage situations of hitting those pop-offs.
Great, thank you. I have another one here related to propane, and it says, when will Emerson have a full line of single condensing units for use with 300 and 500 gram charge?
So we are actually currently in the process of getting ahead of the regulation when they get thing. We have a complete lineup of condensing units that are available that would suffice the 150 gram limits. We are in the process to design even larger ones, applying different compressors as well as different condensers to make sure that we're outside that 300 to 500 gram charge limitations. But as you know, Andre, that has a lot to do with how the evaporator is designed and how that system is structured, with the condensing unit only being half the system. But I think we're in a strong position as soon as that regulation is available that our condensing units will be large enough to meet those higher charge system requirements.
I've got another one here, I guess, related to A2L. The question mentions, you mentioned building codes in 2023, 2024. Could a delay in building code approvals or possibly local fire marshal approvals cause delays in A2Ls for AC, I guess, and/or refrigeration?
The delay in the building codes is where this gets very tricky. The adoption of those building codes is going to be state by state or even each region inside those states. The one thing that we've seen at the state level actually do to quicken that process is introduce some language into their state regulations that allow users in states like Texas or Washington or New York to actually use and design systems as approved by that local authority, as long as they meet the updated UL and ASHRAE regulations with their sign off. So therefore eliminating the need to wait for the finalized building codes. But that will be something that you have to navigate, I'll say state by state or system by system until those final building codes are in place. Therefore, that's why Emerson's predicting, trials to start in 2022 with limited adoption until the 2023-2024 timeframe while those building codes catch up.
Another one here, more on the, I guess, supermarket refrigeration. For national end user accounts tasked with meeting their net zero emission targets, whatever that is, 2040, a lot of them, how can they effectively choose a long-range strategy if they don't have dedicated resources on staff to follow all these state and federal regulations?
For each, retailer, they're going to have to evaluate their own capabilities on their staff and look at the various stakeholders that they've traditionally leaned on, and they're probably have to look at exploring new stakeholders in that system design and consultant process to help them get there. Individuals that come to mind are emerging consultants that specialize in emission or net zero plans, your traditional consultants, stakeholders like Emerson or other equipment providers, or the OEMs that are serving both the air conditioning and refrigeration space. But it's not going to be an easy answer, and it's going to put a lot of turmoil in the years to come as we work through this as an industry, because the experience with these low GWP refrigerants, is limited across the designers of the systems, the OEMs, the installing contractors, as well as the contractors maintaining these stores. So it's going to be a fun 5-year ride for us as an industry.
Yeah, and industry organizations are also putting out a lot of content relative to regulations and simplifying them. Emerson does E360 webinars on a regular basis associated with really understanding those regs and simplifying them to help with the application-based decisions too.
When you're looking at low GWP refrigerants, the under 150 grouping, if you will, how does refrigerant glide factor into choosing the right refrigerant?
So the GWP of a refrigerant is one factor that needs to be considered. Capacity is another one. Glide's a very important one. If you look at the industry's ability to design equipment that effectively uses, zero glide or some glide, or even using glide to an advantage, is unique. The industry overall does have confidence that, glides of around 15 to 18 degrees are traditionally what we've been dealing with. They can handle that in their overall system design. They do have concerns that evaporators or even condensers will need to be completely redesigned if they go much beyond that. And that's why refrigerants like 455A that have that glide of 22 degrees have some concerns when we're looking at it from an overall equipment design perspective.
All right. Thank you very much.
Okay, that's all the time we have for questions today. Thank you again to Kurt, Katrina, and Andre for fielding the questions, and thank you all for your participation. Any questions that we are unable to answer during our time today will be sent out directly to the asking individual in the coming days. Just as a reminder, a few days after this live event, you can access this presentation on demand or view previous E360 webinars at e360hub.emerson.com/webinars, and you'll also receive an email in the next few days with a link to the recorded event. If you want to subscribe to our monthly E360 newsletter and access all of our E360 content, visit e360hub.emerson.com. On behalf of Emerson, thank you for attending today's E360 webinar. Information and registration will be available soon for our next upcoming webinar. We hope you can join us again. Thank you.